Good afternoon, everyone. Welcome back. We're glad you're here. I'm Steve,
And I'm Scott.
and together we're Backyard Musing Science and Technology Channel.
Yep, and we are talking today about a vaccine that it'll be easy to use. Just spraying it up your nose. So this is kind of cool.
Yeah. A single nasal spray vaccine may one day protect against viruses, pneumonia, and even allergies. For decades, scientists have dreamed of creating a universal vaccine capable of protecting against many different pathogens. The idea has often been compared to a holy grail of medicine, a goal that seemed almost impossible to achieve until now. Would you like to know more?
Yeah. So I am definitely I am pro nasal spray.
You're a huffer. You like to huff.
I do the nasal spray. I do the nasal the saline solution, and then I also occasionally use the nasal spray. So this would be great for me. Now, researchers at Stanford Medicine and their more collaborators, say they may have taken a major step towards that vision. In a study conducted in mice, I wonder how they got the mice to do the nasal spray. Come on. The team developed an experimental vaccine designed to defend against a wide variety of respiratory threats, including viruses, bacteria, and even allergens. The vaccine is administered through the nose, such as with a nasal spray, and produced broad immune protection in the lungs that lasted for several months. Wow. Okay. I'm good.
Yeah, the findings published in. Go ahead, Scott.
No, that's right. I was going to say, I like it.
Yeah. The findings published in Science on February 19th, 2026 showed that vaccinated mice were protected from SARS-CoV-2 and other coronaviruses, as well as from Staphylococcus aureus and Actinobacter baumannii, common hospital-acquired infections. Oh my gosh. The animals were also shielded from house dust mites, a common allergen. Yep. According to Bali Pulendran, a PhD, the Violetta L. Horton Professor 2 and Professor of Microbiology and Immunology, who served as senior author of the study, the vaccine has demonstrated protection against an unusually wide range of respiratory dangers tested so far.
So me greasing the palms of the producers is starting to pay off. I like that. So the study's lead author is Heibo Zhang, a PhD, a postdoctoral scholar in Pulendran's lab. If future research confirms these results in people, the approach could eventually replace several yearly vaccines for seasonal respiratory infections and also serve as a rapid defense against emerging pandemic viruses. You got my vote. This is good.
Since the late 1700s, when English physician Edward Jenner introduced the concept of vaccination from the Latin vacca for cow, after using cowpox to protect against smallpox, vaccines have relied on a basic principle called antigen specificity. In this approach, vaccines present the immune system with a recognizable component of a pathogen, such as the spike proteins that cover SARS-CoV-2, allowing the body to quickly identify and attack the real pathogen in the future.
Hey, so do you think in Rome they have a instead of an In-N-Out burger, they have a vodka burger?
Probably. Mm-hmm.
Kind of a catchy name, I guess. Okay. Quote, that's been the paradigm. You're just not into it today, are you? You're just tired, aren't you?
Yeah.
That's been the paradigm of vaccinology for the last 230 years. Pulendran said, okay, what is vaccinology?
That's the study of vaccines, how they react, how to make them. Yeah.
Okay. However, this strategy has limitations. When viruses mutate or new pathogens appear, existing vaccines may lose effectiveness. This is why updated COVID-19 boosters and seasonal flu shots are required every year. Yeah, I'm not down with that. So anyway, go ahead.
Yeah. Most attempts to design broader vaccines have focused on protecting against an entire family of viruses, such as all coronaviruses or all flu viruses. These strategies typically target parts of viruses that change less frequency during evolution. Still, the concept of one vaccine capable of protecting against many unrelated pathogens has long been viewed as unrealistic.
Rather than copying a piece of a virus or bacterium, the new vaccine imitates the signals immune cells send to one another during infection. This strategy connects the body's two main immune defenses, innate immunity and adaptive immunity, and keeps them working together in a sustained response.
Most vaccines mainly stimulate the adaptive immune system. This system produces targeted defenses such as antibodies and T cells that recognize specific pathogens and can remember them for years. The innate immune system works differently. It responds quickly to infection and includes cells such as dendritic cells, neutrophils, and macrophages that attack invading microbes in a more general way. Because its activity usually fades within days, it has traditionally received less attention in vaccine research.
Although innate immunity normally fades quickly, scientists have long suspected that it might sometimes last longer. One clue comes from the Bacillus Clement Guerin tuberculosis vaccine, which is given to about 100 million newborn babies, I guess, each year, right?
Yeah,
wow, that's a lot. Studies that must be Europe, you think? I don't know if they do that here, do they?
Well, it's probably all around the world.
Oh, okay. Studies have suggested that the vaccine can reduce infant deaths from infections unrelated to tuberculosis, hinting that its protective effects may extend beyond its original target. However, the mechanism behind this cross protection has remained unclear.
In 2023, Plundren's research group published a study in mice that clarified how this broader protection might occur. Like most vaccines, the tuberculosis vaccine activated both innate and adaptive immune responses in the animals. However, the innate response lasted far longer than expected.
Okay, the researchers discovered that T cells had moved into the lungs during the adaptive response, were sending signals that kept the innate immune cells active. As long as that heightened innate response remained active, the mice were protected from SARS-CoV-2 and other coronavirus infections. The scientists identified the signals from T cells as cytokines that activate pathogen sensing receptors known as toll-like receptors on innate immune cells.
The new vaccine, currently called GLA3M052LS plus OVA, that's a long one, is designed to mimic the signals from T cells that activate innate immune cells in the lungs. It also contains a harmless antigen known as ovalbumin, or OVA, an egg protein that draws T cells into the lungs and helps sustain the immune response for weeks to months.
During the experiments, mice received drops of the vaccine in their noses. Some animals were given several doses spaced 1 week apart. After vaccination, each mouse was exposed to a respiratory virus. With 3 doses, the vaccine protected mice against SARS-CoV-2 and other coronaviruses for at least 3 months. That's pretty big.
Yeah, that is big. Unvaccinated mice experienced severe weight loss, a sign of illness, and many died. Their lungs became inflamed and contained high levels of virus. Vaccinated mice showed far less weight loss, all survived, and their lungs contained very little virus.
Okay. Plundren described the vaccine's effect as a double whammy. The sustained innate response reduced the amount of virus in the lungs by 700-fold. That's a lot. Any viruses that managed to bypass that first line of defense were quickly confronted by a rapid adaptive immune response.
After seeing how well the vaccine worked against viruses, the researchers expanded their testing to include bacterial infections of the respiratory tract. The vaccinated mice were also protected from Staphylococcus aureus and Acinetobacter baumannii for about 3 months.
The researchers exposed mice to a protein from house dust mites, which commonly trigger allergic asthma. Allergic reactions involve a type of immune response called Th2 response. Unvaccinated mice showed a strong Th2 response along with mucus buildup in their airways. Oh, poor mice. In vaccinated mice, the Th2 response was suppressed and their airways remained clear. Wow, this is very promising.
Yeah. The researchers now plan to test the vaccine in humans. The next phase will begin with phase 1 safety trial. If those results are positive, larger trials would follow, including studies in which vaccinated volunteers are exposed to infections. Pulendrin believes 2 doses delivered as a nasal spray could be enough to provide protection in people.
With sufficient funding, he estimates that a universal respiratory vaccine could become available within 5 to 7 years. Holy cow. Such a vaccine could strengthen defenses against future pandemics and simplify seasonal vaccination. Okay, 5 to 7 years. Bring it on, man.
FDA.
Bring it on.
Yeah, that's what I'm saying. I'll test. I'll do it.
If we could cut it down to 2 to 3 years or 4 years, does that mean we need to send them more money?
Give me your money.
Yeah, more money means less time, or maybe more time because we want the money to keep rolling in. So,
all right,
anyway,
folks.
good topic.
Thanks for joining us. We'll see you tomorrow.
Yep. Have a good Monday, and we'll see you on Tuesday. Thanks.